this tutorial, the workflow is broken into 4 steps. First, the project is geo-referenced to establish a reliable spatial foundation. Next, the BricsCAD project structure and IFC framework are defined. From there, IFC data is brought into the coordination model and used to demonstrate how geometry and information can develop over time. Finally, the model is exported to IFC for validation and spatial coordination using the new export dialog introduced in BricsCAD V26.2. The datasets used in this tutorial can be downloaded using the link in the notes. Let's get started. Step 1 is to geo-reference the project in BricsCAD. In this example, the drawing is set to work in meters, and based on the BIM execution plan provided by the project team, the project uses the CRS EPSG 3812. There is also a known Cartesian coordinate for the site. This is a conversion from the northing and easting values provided with the coordinate reference system. Start by confirming the drawing units with the units command, and change them to meters if needed. Then run geographic location and assign EPSG 3812 in the geographic location dialog. Once that is done, use the known coordinate to establish the project position in the DWG. Next, place a point at the coordinate using the point command. Then, open GeoMap to verify that it's been positioned correctly. With the online map or aerial imagery visible, you can confirm the site location and assess how the parcel sits relative to the XY grid. In this case, the parcel rotation is recorded as 103.75 degrees. This is a rotation relative to the XY Cartesian grid, not a true north bearing. Once the position has been verified, create a rough sketch of the parcel boundary directly in the drawing and save the file. At that point, the DWG is geo-referenced. The parcel is established in its correct spatial context, and the site sketch is ready to support later coordination steps. For surveying contractors, this file can also serve later as the basis for establishing shared coordinates with Revit assets. For now, the objective is to establish the source spatial reference correctly in BricsCAD. Step 2 is to establish the BricsCAD project structure and define the basis for IFC organization of the model. In this workflow, the general coordination model is the main working file. Open that file first, then create or establish the BricsCAD project associated with it. Save the project database as project.bsyslib in the project root directory. This is also where you can establish various information according to your project and office standards. Confirm that the folder structure matches the extracted package and use the project browser to add the required drawing sheet DWGs to the project. At that point, the BricsCAD project becomes the central repository for related drawing and model assets, and the structure is prepared for importing and updating geo-referenced IFC content as the project develops. With that project structure in place, the next step is to define the IFC framework that will organize the model. This matters because IFC is not only about geometry, it also depends on a clear project structure so that model elements can be understood in the right context when they are exchanged with other tools. At this stage, the structural grid is also laid out. In this case, open the sketch drawing that has already been included in the project. Simply use the copy-paste command and paste the grid to the point object we placed earlier. Once the grid objects have been created, use the BIM classify command to classify them as IFC grid. That matters because the grid is no longer treated as a generic line work. Instead, it becomes a recognized IFC entity that helps communicate layout alignment and spatial order across the model. Step 3 is to bring IFC data into the coordination model and decide how that data will be used as the project develops. In BricsCAD, IFC files can be brought in using two different approaches. The first is direct IFC import. This brings the geometry into the DWG as native content and allows it to be manipulated directly within the drawing environment. For this, make sure the XREF checkbox is unticked. That can be useful when the imported geometry needs to be reused, adapted, or developed further as part of the modeling process. The second approach is to import the IFC file as an underlay using an XREF style reference workflow. For coordination workflows with geo-referenced assets, the underlay method is recommended, with IFC placement set to global origin to WCS origin. In this workflow, the architectural, structural, mechanical, and electrical IFC files are each attached to the general coordination model as IFC underlays, using the established shared CRS and project coordinates. Step 4 is to export the model to IFC for downstream validation and spatial coordination. To begin, run the IFC export command. BricsCAD first asks which geometry should be included in the export. After confirming the geometry, specify the file name and export location. BricsCAD then opens the Export to IFC dialog box. The dialog includes two tabs. One tab is used for export metadata, including fields such as the model author and authoring organization. The main tab is where the export settings are defined. In practical terms, this tab helps the user make three decisions: what to export, how to structure it, and how much information to include. The first decision is what to export. The second decision is how to structure the export. At the top of the dialog, the Choose Setting Profile dropdown allows the user to select, save, and reuse predefined profiles for different delivery needs. Depending on the use case, that might mean a profile optimized for viewer compatibility, a more complete design transfer, or a lighter file with reduced size. Below that, the IFC version setting allows the user to select the target schema or model view definition, including options such as IFC4 reference view, IFC4 design transfer view, IFC 2x3, and IFC 4x3. Together, these settings shape how the receiving platform will interpret the file and how suitable the export will be for reference, coordination, or continued development. The third decision is how much information to include. Additional options in the dialog allow the user to control how detailed and how robust the exported IFC should be. This includes settings that affect quantities, spatial relationships, GUID generation, syntax validation, and how certain geometry is written into the file for downstream reliability. The user can also define the tessellation level and choose whether to export all properties or only those captured through an imported IDS. These controls allow the export to be tuned for either broader model richness or a more constrained and purpose-driven information delivery. If you would like to follow the same workflow yourself, you can download the project dataset using the link in the notes. And to learn about how BricsCAD BIM and BricsCAD Ultimate support open BIM workflows, IFC exchange, and multidisciplinary coordination, visit the Octave BricsCAD website.